Hi, I'm Russell Foldsmith, and I'm going to do just a very quick session with a variety of what popular culture seems to be calling AI. I'm not going to debate whether this is actual AI or general AI or narrow AI or machine learning or whatever. Point is, there are some experiences on a computer that some people call artificial intelligence. Whether the people making it or the people using it or whatever, it doesn't matter. So I'm going to use some of these tools to make a couple of points to help people think through this. First and foremost, I view all of these tools as different interfaces and experiences to help your own thinking. I think of them as Socratic computing, Socratic computation, where primarily they're assisting you in formulating your own thoughts and expressions and things like that. So let's just get into the most obvious one. It's all the rage right now, this chat GPT. I've been doing this for probably 20 years, meaning interacting with these tools, either in a conversational interface, search engines, knowledge management tools, scripting programs, video game experiences. To me, they're all the same thing, so I'll talk about this in very strange ways compared to everybody else. But in the end, here's the latest iteration of how to interact with a computer in a non-deterministic way. And what I mean by that is this thing may do things that surprise and excite and delight or disappoint you, just like humans. It doesn't mean it is a human, I'm just saying it's very inconsistent. So ChatGPT was released by OpenAI. It's an interface on top of its existing large language models. These are giant machine learning models trained on gazillions of words and sentences and text out there on the internet, in the human published corpus of things. And this is just an interface, literally a way for you to use these models. And it's a conversational interface, but it's caught a lot of people's imagination. So let's just get into this. And my approach to these things is not try and tell them what to do or give them a very specific instruction, but it's to kind of get into a flow with them. So I'm just going to start. I am looking to have a Socratic exploration of some topics and ideas on my mind. Please try not to make up facts, but maybe be imaginative in helping me understand things. And what I'm trying to do here is just prime it. And what I call prime it is give it some context. Just give it what I'm thinking about. And it doesn't mean that it understands what I'm thinking about or that it's thinking. I'm just going to give it some content to kind of set this conversation up. So kind of interesting that it's comfortable showing me that somewhere in the model, and I don't want to get too technical, but somewhere in the model, it has some reference point to Socrates and what the Socratic process might be about, and some of the content areas. And I want to be very clear without getting too technical on an engineering standpoint or linguistics or statistics or anything like that. But what's actually going on here is this large language model is just doing what's called a sequence-to-sequence prediction, or a sentence-to-sentence, or a word-to-word, or a token-to-token. It doesn't matter how you talk about it. Point is, it's taking what I wrote, and based on all of the other text trained in the model, it's trying to predict what would come next, in the most common usage of these words, meaning these words I typed, what likely, are grammatical and valid sentences. It doesn't know that, but because humans tend to write in a grammatically valid way, that grammar's kind of in the model, like in an emergent way. So grammatically, it will respond correctly, and then it's trying to predict the words that would be attached to that set of text that I put in. So here, again, you can read it on the screen. I don't want to read it all out. This is part of the challenge of these systems, is that now that they're able to do a lot more in terms of responding to what I'm writing, I have to read a lot more. So you have to read too. I can't read it all and type and think and converse with this. So there's a lot of things going on here. So again, this is a Socratic computation where for me to understand what's going on, I actually have to participate in the process. Here are a few examples of topics or ideas that we could explore through Socratic exploration. Okay, so there's a lot of context in this conversation already. I guess maybe I'm learning what in the model, deep inside this model, beyond this user interface, what context I might be able to pull from. So, okay, great. Seems to be some general language terminology that we can build from. So, to make this maximally useful to people who might be watching this, probably educators, learners, students, interested people who are trying to figure this out. Let's talk about education. First topic is on the nature of knowledge and education and how individual learners acquire knowledge. As a second concern, what are the possibilities for computers to aid in that process of learning? Now, in a way, there's something that's been revealed by how quickly the machine comes back for information. A human would never respond that would start typing that quickly. I mean, yes, in a chat conversation you may do that, but a human generally isn't going to have an immediate coherent response to such a difficult topic. So that's the first clue that you're not dealing with something human, and that it's the machinery behind it fundamentally is just working very different than humans would work. That doesn't mean it's invalid or wrong or bad or we should ignore it or not use it or whatever. It just means know that you're dealing with something that isn't human. It's not even human-like. It is statistical in how it's dealing with language. So I got to reread my question because I lose track of the thought. First topic is on the nature of knowledge and education and how individual learners acquire knowledge. Second concern I have are what are the possibilities for computers to aid in that process of learning? The nature of knowledge and education is a fascinating topic, and there are many different ways that individual learners can acquire knowledge. One key aspect, I'm scanning like a human does. I don't want to read all this. And the machine doesn't scan like that. It literally is creating probabilities between all these words, so it doesn't have this sense of scanning. Or maybe it does. I don't know how to think about how these neural networks build up, but maybe there's some idea of scanning that we just don't know about. This is a really long response. Why is that? Because I can do other things where the response won't be so long. It's because Socratic explorations, as humans have written about them and published them on the internet, tend to be very verbose. So if I were picking a topic that tends not to be verbose in the English language, I probably wouldn't be getting these long responses. So for example, if I were doing mathematical equations, I would not be getting answers this long. So there's just little clues I'm giving you along the way of what you're dealing with here. Additionally, computers can be used to personalize the learning experience for individual students. Okay, that's kind of useful. Overall, computers have the potential to greatly enhance the process of learning, helping acquire more. So I'm kind of getting some clues here. It can also be used to track a student's progress. Generally fine things. For example, a student might memorize the formula of the area of a circle, but they will truly not understand the concept. That seems like a fun thing to start an actual exercise on. Okay, let's key in on your example of memorization of the area of a circle versus learning the concept of area and circle and formulas and geometry and math, right? This is to me what's coming to my mind. So, do we think we always have to start by offering an advanced concept like area, geometric area, already worked out? Or can we build knowledge up, build knowledge from the ground up between a computer and a learner. Ugh, that was a lot to type. Okay, so it's suggesting you see what's happening here is I'm sort of evolving my thinking on this in a couple different ways. I'm trying to do this video and give you a demonstration of a Socratic process. I'm also trying to take seriously the concepts being discussed here, and I'm potentially updating my own ideas, and I'm trying to make sure that this computer interaction is actually fruitful. So it's like lots of levels in which I'm trying to optimize this. It may be beneficial to start with advanced concepts. In general, the best approach to learning is likely to be a combination of both starting with advanced concepts. I mean, there's a lot of kind of Socratic verbalization. I don't know how much each of these thoughts is actually that useful. By providing a balance of challenging and accessible material, I think I want to get it to actually do something. Okay, so let's do something then. Let's compose a lesson plan for a learner to explore the concept of a circle and its geometric properties. I'm going to pop over to WolframAlpha, and I'm just going to do, because it will satisfy me, area of a circle. In a lot of ways, it makes a slightly different point, where I'm not getting this slow-moving verbal dump. Instead, I'm getting a lot of interactive, I don't know what to call this, multimedia interaction on WolframAlpha, where I get the formula, I get a visualization, I get some tools that I can play with, and I've even got sources if I want to explore deeper. Now, this interface, while some of it is like very approachable and very human, very humane, I don't know how to say it, it also, it's not quite clear what level of learner it's targeted at, and there's no real way to say, hey, give it to me in a simpler way. So, but it helps me think through it to have these different things. Now, I'm going to use DALL-E at the same time. So let's do area of a circle presented to let's say elementary school student. See, another point here is you got to have all these reference points. Like, why would I say elementary school student instead of lifelong learner or something like that? I know something about how people have published mathematical concepts, lesson plans online, and so I tend to use the most common reference points to help people, help the machine find the most likely content out there. So we'll let DALL-E get to work and present some content on this. Now we have a different problem that's shown up. So this is where I learn about things, where I've got circles, not surprising, it's got some circle ideas, but here you become, it's very messy. Because the model that's powering DALL-E is meant to be more artistic or interpretive, and so very strict formal concepts like the area of a circle really don't have a very direct path to just request that. So I'm in a little bit of a bind here on how to think about this, because now you as the human have to make some interpretation of whether this is valuable. So you can't really use DALL-E as a diagrammatic tool like you could WolframAlpha. So now, but maybe we can try that. Diagram a factual, formulaic depiction of the area of a circle for primary education students in a textbook. I mean, this is horrifying what I'm typing because I'm referencing all these things I don't want to reference. But I'm trying to see if I can get anything in the realm of a helpful visual artifact. And the fact is I can't. None of these concepts actually make the area of a circle clear. They're quite fun. I mean, I want to save these because I find them very fun. Make a point. So, it kind of, I've now bounced between three modalities that give you very different ways of thinking it. WolframAlpha is a mathematically precise algebraic system that does provide diagrammatic information. DALL-E is artistic and interpretive and metaphorical, where ChatGPT is very verbal. So now, let's go back to ChatGPT and think through this. We have this very complicated lesson plan that, to me, I already know. I'm not going to read it all. It seems very fine that the idea is here. I'm going to go back to it, but I'm going to play with it a little bit. Summarize, simplify this plan. Simplify this lesson plan for middle school student. Let me do elementary. Let's see if it can handle that. Let's see. Okay, so instead of geometry, it's talking about shape. So we're still in this meta level thing where it's bringing back text for me to consume, and what I want to try and get it to do is put together a plan that I can hand directly to the learners. And by the way, this is a very traditional lesson planning. I'm not suggesting I've invented a new lesson plan. Instead, I'm trying to use this as a Socratic way to explore these topics, both of the Socratic computation, but also can we actually get it to be productive in whatever ways that we want. Okay, now write this as a lesson plan. Maybe if I don't call it a lesson plan, as a set of exercises and projects I can give directly to elementary school students. So while that is coming up with the lesson plan, this is kind of fun. So we actually got somewhere useful. While it's writing that out, I went ahead and went to WolframAlpha and I gave it a radius 2 on the area of circle because I want to show the step-by-step solutions. So in WolframAlpha, the idea of doing interactive learning is this step-by-step solution. So you can actually see where it actually applies the math and the geometric reasoning. Kind of get it. You can go next step, gives you hints along the way. Start over, and I'll show all the steps on the screen at once. So you can get more advanced, but let's just do a circle because most of us can understand a circle. Okay, measurement challenge, give the students a hula hoop, circular object, that's pretty neat. Scavenger hunt, that's pretty neat. Okay, these are pretty reasonable. Let me see if I can get it to make an artifact that I would actually want to print out. Put those projects in a table format with a column for the project name, expected learnings, and date to complete. Now, it's going to recognize in this interface when you can make a table. So that's actually a pretty useful thing that if I like these projects and they're rank ordered kind of usefully, I would just turn that into a Google Doc. I would cut and paste, put it in a Google Doc. So now let me, I'm going to see if I can do something advanced. Take row 3 and put it as the first project in December 2023. I want to see if it can reason about its own table. Yeah, it did it. Well, but now it didn't complete the rest of the table. So now we're seeing some of the challenge of a Socratic computation, which is it was quite advanced in recognizing the third row without counting the column headers, but then it didn't really understand what I meant. Complete the full table though. So sometimes I got to prompt it along, but now I've lost a sense of that last command. So this is where if you were working in Google Docs or some other interface, you would go ahead and just manually manipulate that with your mouse and your keyboard. You wouldn't waste a lot of time sitting here trying to use linguistics to move the stuff around. So now let's add an advanced concept. How effective do you think this set of exercise be on learners who have never explored? This is sort of like asking an opinion assessment question, which you may be tempted to do, but I would be very suspect of what's going to come out of this. Because we just sort of invented these projects on the fly using the statistics of language models, and it's not like somebody at OpenAI is a mathematics educator who's deeply sat down and thought about all the lesson plans and the pedagogy and figured out the optimal way to evaluate these things. So you're really not going to get, if you tempt yourself into this line of Socratic engagement, you may take yourself off track. So maybe that's useful information to you, I don't know. I'm gonna do one last thing before I cut this video and put it out there in the world. Just to show you, again, I could do a lot of different things to kind of wow you, but this is what's kind of fun about this. Write a JavaScript program for each of the projects you put in the table. So now it kind of got tripped up. I think if I just told it to write a JavaScript program about a circle, it will probably do okay. I'd like to write a JavaScript program exploring the ideas of the area of a circle for elementary school students. Now, I happen to be a programmer, so I'll be able to detect pretty well if this is like a useful program. If you're not a programmer, I don't know how useful this will be for you. So I reframed the question so it didn't have to pull in so much context and kind of air out. You wouldn't have known to do that if you weren't a seasoned user of these kind of systems, but I knew in what was happening here that this response wasn't like a legitimate response to its ability to compose these programs. I knew that it could. And so I just reframed the question in a different way so it could get there. Because you may be working with humans, human learners, that sometimes you just got to rephrase the question. You may find that completely annoying to do with a computer, but I think it's the most effective way to use these systems is not give up. So I happen to know that this looks a lot like WolframAlpha's formula for a circle. So that looks pretty good. And that would actually run. I know that would definitely run. I've built other systems where anytime that GPT-3 creates code, it actually attempts to run the code, and if it runs successfully, it saves that out and says that it ran successfully and tries to explain the code. If it runs unsuccessfully and errors out, it tries to correct the error and get to a valid program. So this interface could definitely go down that path. It kind of uses a different thing. Rather than run the code, it actually tries to explain the code right here. Give you some ideas. So I'm going to close out there on this video because that was a lot of content. But this, to me, I did an entire session of what I consider Socratic computing and using different computer systems to evolve my thinking on the topic. I hope you find this useful and illustrative. I do not encourage people to use these systems to replace your thinking and your fact-finding and your search engineering. I do believe that these systems are incredibly powerful to evolve your own thinking. But ultimately, you still got to do thinking. So thanks for listening if you're listening. Please do tell me how I can be helpful to anybody out there.